Algebra 2, Section 6-3, Square Root Functions and Inequalities. So we are going to learn how to graph square root functions and inequalities, just like the title said. So let's look at what the parent graph of square root of x looks like. So let's just do a little t-table real quick. I get to choose whatever values I want in here. So I'm going to choose easy ones. So 0, when I plug in 0, I get 0. I plug in 4, the square root of 4 is 2. How about 9? Plug in 9, the square root of 9 is 3. Okay, so 0, 0. Then I have 1, 2, 3, 4, 1, 2. And then I've got 9, so 5, 6, 7, 8, 9, and 3. It's about right there. So your square root function looks something like this. Now, notice how it's not a straight line. A lot of times, if I were to draw this to scale, you might see it better if I were to draw it like this. It's curved like that. It's like half of a parabola. So your domain here is 0. Just notice 0 is included, and it goes to positive infinity. Oops, this should be, sorry, soft bracket for infinity. Your range is 0, so your y values that are included, and that goes all the way up to infinity as well. And so you can write this same thing as, let's see, how would they do it in the book? For x values, x is greater than or equal to 0. Something like that. Okay, for the range, for whatever. Now, f of x equals -1 is undefined. So what I mean by that, or what the book means by that or whatever, is if there's negative inside the root, inside of the radical, it's undefined. That's why this goes like this and doesn't go down in here, because you can't have a negative inside the radical for this graphing thing. All right, let's do some examples here. First, we're going to start with identify the domain and the range. We're going to graph and identify the domain and range. We should say graph first here. Okay, graph and identify the domain and range. Here's an example. F of x equals square root of x plus 4. So let's graph this. Whenever you're not sure what it should look like, just make a t-table and plug in values. So here's x and y. Let's plug in 0 for x, and that'll get us the square root of 4, which is 2. And then we just plug in some other numbers that make it easy to take the square root. So 5 plus 4 is 9. So let's say 5 plus 4 is 9. Square root of 9 is 3. And let's do one more, -4. So -4 plugged in here, that would make this whole thing 0, so y will be 0. So let's, here's what the parent graph looks like. Let's go 0, positive 2. There's 1 point there. And then 5, 3. 1, 2, 3, 4, 5. 1, 2, 3 is about right here. And -4, 0. Or actually, this maybe should be a little bit lower, right? -4, 0. 1, 2, 3, 4, 0. So here is the new graph. This one should kind of go like that. Okay, so what happened? It moved to the left 4. Everything stayed the same, except for moving to the left 4. So notice this is plus 4. So when it says plus 4, we move left 4. And we'll see some examples that don't look exactly like this. If there's something multiplied by the x, we're going to look for the x value that makes this 0. But we'll see that in a bit. So the domain here is -4, and that's included, and it goes to the right forever, so positive infinity. The range is here at 0. Looking at the y value here is 0. It's included, and it goes up to infinity. Even though it doesn't look like it's going up, it's just going to keep going up, but it's just going to go way over to the right to get up. Okay. Let's do another example. F of x equals the square root of x plus 6 plus 2. Notice the plus 2 is outside of the radical. So if you want to do a t-table, you can do a t-table, but I'm also just going to tell you that this out here, this plus 2, makes this whole thing go up and down. If it's negative, it goes down. If it's positive, it goes up. So if I go up 2 here, here's my parent function. Now this one, I know I go -6, so I go that direction 6. 1, 2, 3, 4, 5, 6, and I know I go up 2, so there's my new starting point. I went up 2 and to the left 6, and so now there's my my graph. And I want my domain and my range, so the domain is, I'm just looking at the x values here. The x values are, I'm at -6 here, -6, positive infinity. Now my range, I'm just looking at my y values here, and so I went up 2, so 2 is included, and it just goes up forever, so that's positive infinity. Okay, let's have you try one. F of x equals the square root of x minus 3. Notice this is -3, the other ones were plus 6, plus 4. So this one is -3. So you're going to start, I'm going to get you started, and then you're going to do the rest. Start like this, and here's your parent graph. And now decide what to do with this and graph it. Okay, pause and graph this guy. And do the domain and range. Okay, let's see how you did. So this one, since it's -3 here, I'm going to move to the right 3 instead of to the left. 1, 2, 3, and there aren't any other manipulations to this, and so that's it. If you wanted to do a graph, a t-table, go ahead and do a t-table if you weren't sure how to do these transformations here. So like if you were to plug in 3 here for x, then you get 0 for y. If you were to plug in, let's see, 12, then that would get 9. Square root of 9 is 3. And then 7, that's 4, square root of 4 is 2. Okay, so you can plot those points. You can see 3, 0, 12, 3 is way over here, and 7, 2 is like right about here, right? So that's another way to do it. We need the domain and the range. So the domain, the x values, start at +3, and they go to infinity. The domain, the y values, start at 0, and go to positive infinity. Okay, we need to do one more, we need to do one more example here, because you need to see one other type of situation. So I've got f of x equals the square root of 2x plus 5. So notice here I've got a number here next to x being multiplied by the x. And so my parent graph looks like all the other ones, just like that. Now, I need to figure out where this starting point is going to be. If this 2 wasn't here, I would just go back 5, go to the left 5, and that would be my new starting point. But I've got 2x minus 5. And so what I need to do in order to find that starting point is I need to say 2x plus 5 equals 0. Subtract 5 from each side. And then I've got 2x equals negative 5, divide by 2. X equals negative 5 over 2, which is negative 2.5. So I need to go to negative 2.5 is where, how far to the left I'm going here. So negative 1, 2.5. Gross. But that's the way it is. Now you could plug in a bunch of points to find the rest of this, but finding that starting point, it's going to be pretty hard to find this negative 2.5 here. Okay. Because that's what makes this 0. And so that's how you know that's the starting point. Okay. If it said like plus 2 over here, then the starting point would be negative 2.5 plus 2. But since there's no transformations out here, then we just go back to there. All right, let's do another U-try. And this one is, so we're just going to graph this. Y equals the square root of x plus 2 plus 5. Notice the 5 is outside of the radical sign. So I'd like you to graph this one. And go ahead and go, graph it. Oh, we want to graph it. I should have said this before we got started. Graph this, and I also want 3 points. Okay, so let's see how you did. Minus 2, so I go back 2, 1, 2, and up 5. 1, 2, 3, 4, 5. There is my the starting point of my transformed graph. So it's going to look like this. But I need 3 points because I said 3 points. So if you didn't do the 3 points, go back and do them. 3 points, x and y. So I'm going to plug in negative 2 for x. That gets me 0 in here. That's the one I found already. And so I get 5 for y, because 0 plus 5 is 5. Now I'm going to think what else. If I plug in positive 2, then I'll get 4. Square root of 4 is 2. 2 plus 5 is 7. So if I go to 2, then I go 5, 6, 7. There's my point, so it should look more like that. And then I'm going to plug in, let's get this to be 9, so I'll go 7 plus 2 is 9, so 3, square root of 9 is 3, plus 5 is 8. 7, 1, 2, 3, 4, 5, 6, 7, and then all the way up to 8, which is right there. And so there's my new graph. Okay, I'm going to have you try another one. This one is a little bit more tricky, but it's good. So, you try. So remember those 3 points. That's going to help you on this next one. Y equals negative 2 times the square root of x plus 3 minus 1. All right, don't be scared. We're seeing something we haven't seen before. This is going to do something to this whole graph. But guess what? You don't even need to know what it's going to do yet. All you need to do is do a t-table, and you will find out what it's going to do. So draw your coordinate plane and get your t-table started. Let's see, I'm going to get your t-table started. Find at least 3 points, and let's see how you did. All right, pause and get this one done. Okay, let's see what this -2 does here. So I'm going to plug in some points here. I'm going to make this 0. So I'm going to plug -3 in for x. And so that'll make this 0. 0 times -2 is 0, minus 1 is -1. Okay, there's 1 point. Now I'm going to plug in another one that's going to make this easy. Let's see, +1. If I plug in +1, that gives me 4. Square root of 4 is 2. 2 times -2 is -4. -4 minus 1 is -5. Now I'm going to plug in, let's make this 9, so I'll plug in 6 for x. Square root of 9 is 3. Times -2 is -6. Minus 1 is -7. Shall we do one more? Let's do one more. Let's make this 16. So let's plug 13 in for x. 13 plus 3 is 16. Square root of 16 is 4. 4 times -2 is -8. Or minus 1 is -9. Okay, we got 4 points. Let's graph it. -3, -1. 1, 2, 3, -1. 1, -5. 1, -5. 1, 2, 3, 4, 5. Ooh, that's weird. Let's do another one. 6. Oops, right here, sorry. Then we've got 6. 1, 2, 3, 4, 5, 6. And we go down to -7. So if this is -5, 6, 7, right here. And then we've got another one. 13 is way over here, and -9 is going to be down here. All right. So our original guy looked like that, right? Now this one looks like this. So this -2 here, notice it flipped it. So this makes it flip on the x-axis. Flip on x-axis. That's what the negative does. The 2 squishes or elongates it. I'm just going to say squishes. So it made it steeper. This -2 made it, the 2 made it steeper. Okay, great. So I want you to do one more. We're going to jam it in here. One more you try. F of x equals 2 times the square root of x plus 4. All right. So we did another example here that had a number in the front. This one is positive though. All right, let's see how you guys do. Go ahead and do this one. Go. All right, let's see how you did. Okay. Let's just do a t-table. So if I plug in -4 for x, I get 0 in here. Square root of 0 is 0, times 2 is 0. Okay, if I plug in 0 for x, then I get +4 in here. Square root of 4 is 2, times 2 is 4. Let's plug in 5 and get 9. So square root of 9 is 3, times 2 is 6. I think that's probably enough. So let's go -4, 0. 1, 2, 3, 4, 0. Notice, if I were to plug in -4 here, I'm moving to the left 4. So that's my new starting point here. 0, 4. 0, 1, 2, 3, 4. And 5, 6. 1, 2, 3, 4, 5. 4, 5, 6. There we go. And there we have it. So your graph should look something like that. Notice how this is steeper than some of these other ones that we drew. These are more flat, right? more flat. These ones are steeper because they are multiplied by 2 here, so they get squished this way or pulled this way. I don't know, however you want to say it. All right, last example. And this is an inequality. Okay, no problem, inequality. Y is less than the square root of x minus 4 minus 6. So let's just graph this inequality. And we're just gonna do this one together. If you want to graph the function, like pause and graph the function, and then I'll show you how to do the inequality part, that'd be awesome. Otherwise, I'm just going to keep moving. So I'm going to, I know I'm going to go to the right 4, 1, 2, 3, 4, and I'm going to go down 6. 1, 2, 3, 4, 5, 6. That's my starting point there. And my, not parabola, my root function is going to look something like this. So if I were to find 3 points here, it would make my root function look something like this. Now, I need to look at my inequality sign, and I'm kind of going like this. Notice how it's not or equals to. So this is not included in my solution, so that means that this function here needs to be dotted. And y is less than this, so that means I just shade underneath. And I can draw like a kind of a straight line down like that, and that is it. I'm all done. That's how you do the inequalities. So just pay attention to the sign. Y is less than. If it was greater than, I would shade above. Less than, I shade below. And if it's or equals to, then I have a solid line. It's not a line, but and then if it's not or equals to, then it's dotted. So we just apply the principles that we've learned in the past on this. And that is 6-3. Good luck on the homework.